Let knowledge flow like a river without any hindrance. Don't make it like a stagnant pool. Design and analysis of one-way R.C.C slab as per IS 456. Hello everybody, I'm PS Chatterjee with you. Today, I'm going to explain how we can make a pro forma in Excel spreadsheet for the analysis of one-way slab for the residential buildings. Minimum requirement for that IS 456-2000, SP 16-1980, SP 34, S&T 1987, IS 875 Part 2 1987, Excel Software 2010, any standard book. This is our one-way slab. This is LY and this is LX. The primary condition for one-way slab is Ly by Lx must be greater than 2. Types of one-way slab. According to the edge condition, we have divided it into 3 categories. Case number 1, 2 long edges continuous. Case number 2, 1 long edge discontinuous. Case number 3, 2 long edges discontinuous. Say this is our plan. For this slab and this slab, 2 long edge is continuous. So it is case number 1. For this slab and this slab, 1 long edge continuous. So case number 2. For this slab, 2 long edges, this edge and this edge are discontinuous. So case number 3. Important clauses regarding one-way slab design. All the important clauses I have discussed in my previous lecture video of design and analysis of two-way R.C.C slab as per IS 456 is also applicable for one-way slab. Important note regarding the bar size and spacing detail from SP 34 S&T 1987. Note number 1 for main bars of the slab. The minimum diameter of the bar should be 8 mm for deformed bar. For plain bar, the minimum diameter should be 10 mm and spacing not less than 3D or 450 mm. Note 2. For distribution bar of slab, diameter should not be less than 6 mm. Spacing should not be less than 5D or 450 mm, where D is the effective depth of the slab. Coefficient of moments for one-way slab along short direction. Case number 1, 2 long edges continuous. Hogging moment at top 1/12. Sagging moment midspan 1/16. Case number 2, 1 long edge discontinuous. Hogging moment on continuous edge 1/10. Sagging moment midspan 1/12. Case number 3, 2 long edge discontinuous. No hogging moment, only sagging moment at the midspan 1/8. This is our modification factor for the tension reinforcement chart. Here you need to calculate the Fs. The Fs is equal to 0.58 into Fy into area of cross section of the steel required divided by area of cross section of steel provided. This is our section through the middle of the long direction. This bar bars are main bar in LX direction, and this bar is distribution bar. Two long support are continuous. Case number 1. Section through the middle of the short direction. One long support is continuous. Case number 2. Section through the middle of the short direction. One long support is continuous. Case number 2. Section through the middle of the short direction. This is two long support are discontinuous. Case number 3. Section through the middle of the short direction. Now I am switching over to the Excel spreadsheet for the actual calculation. Welcome to my Excel spreadsheet. This is design of one-way slab. Now the parameters are FCK, characteristic strength of concrete, FCK is equal to 20 Newton per millimeter square. Name of this cell is FCK. Characteristic strength of reinforcement, Fy is equal to 415 Newton per millimeter square. Name of this cell is Fy. Unit weight of reinforced concrete, GC. Name of this cell is GC. Partial factor of safety, S is equal to 1.5. Concrete cover at support 20 mm. Concrete cover at span 20 mm. Minimum percentage of reinforcement is equal to 0.12%. P minimum. XU max is equal to 0.0035 divided by 0.0055 plus 0.87 Fy divided by E, that is 2 lakh. Mu by BD square, Mu limb by BD square is equal to 0.36 XU max D into 1 minus 0.416 XU max D into FCK. PT limit is equal to round up 100 into 0.36 FCK divided by 0.87 Fy into XU max D up to 3 digit. All this formula I have used here, you will get it in SP16. K1 and K2, two coefficient. K1 is equal to 1.005 divided by 1.15 into Fy square divided by FCK. K2 is equal to minus Fy divided by 1.15. As we know, one-way slab are three types. Number 1, two long edge continuous. Number 2, one long edge discontinuous. Number 3, two long edge discontinuous. This is slab mark S1, place first floor. This is Ly, length in longer direction, is equal to 7500 millimeter. Length of the shorter distance Lx is equal to 3500. Slab thickness we considered 120. Case number 2, that is one long edge discontinuous. Floor finish load 1 kilonewton per meter square. Other dead load 1.5 kilonewton per meter square. Live load 3 kilonewton per meter square. Total load, dead load, thickness of the slab E16, that is thickness of the slab, divided by 1000, that is in meter, into unit weight of concrete 25 GC, plus this load and this load, total 8.5 kilonewton per meter square. If we change the case number, this panel type will change. Say it is 1, 2 long edge continuous. If 3, 2 long edge discontinuous. Ly by Lx is equal to 2.143. Ly by Lx greater than 2, one-way slab, okay. Selected bar dia 10. Spacing provided 110 and for top, and for bottom it is 10 dia and 125 spacing. Now this is moment coefficient. I have written here if 22, F22, this is F22. If F22 less than equal to 2, then it is not applicable. Otherwise, round off. If F16 is equal to 1, that is case number is equal to 1, then it will be 1 by 12. If case number 2, it will be 1 by 10. And if case number 3, it will be 0. Similarly, if F22 less than equal to 2, not applicable. Otherwise, round up. If F16 is equal to 1, then this value will be 1 by 16. If F16 is equal to 2, then this value will be 1 by 12. If F16, that is case number, is equal to 3, then it will be 1 by 8. Mu is equal to partial factor of safety, that is this partial factor of safety S into total load J16, total load J16, moment coefficient. This is total load and this is distance L square, Lx square. Similarly, for long direction, partial factor of safety, total load into this value, that is D16 is equal to Lx. This is sagging moment, this is hogging moment. Mu by BD square is equal to this mu into 10 to the power 6 divided by B. B means 1000, 1 meter, 1000 millimeter, into D. D means thickness. This is E16 thickness minus top cover at top A24 CS support, cover at support, minus half of this diameter A24. This is A24. Similarly, for bottom, mu by BD square is equal to this value mu into 10 to the power 6 divided by 1000 into square of the effective depth. Round up to 2 digit. PT required is equal to round up max A if H24 less than mu lim by BD square, comma, into, comma, 100 into minus K2 minus square root of K2 square minus 4K1 into H24, that is this mu, and 0.12 minimum percentage of steel up to 3 digit. Similarly for bottom, AST required, this is percentage of steel. This percentage of steel I24 divided by 100 into 1000 into E60, that is thickness, total thickness, gross thickness. Similarly for this, AST provided 1000 divided by spacing plus 1. 1000 divided by spacing plus 1 into 0.25, that is pi by 4 d square, that is 10 square, A24. Now percentage of steel provided is equal to 100 into K24, that is AST provided, divided by 1000 into effective depth of the slab. Similarly for bottom reinforcement, spacing required is equal to round up 1000 millimeter divided by J24, that is AST required, into pi by 4 d square, that is this is d but dia d square. Now once again we have written here spacing provided. This is equal to this one. Similarly for bottom reinforcement, the spacing required is equal to round up 1000 into Z25, that is this one, into pi by 4 d square, d is equal to 10 mm. Bottom reinforcement. Once again we have written here spacing provided, taking the value from here. If this value is more than this value, the design will not be okay. Now check for the deflection. Fs is equal to 0.58 Fy, AST required by AST provided. Basic Lx by d on the basis of the case number. Here I have written, if the case number is 3, then basic Lx by d will be 20. Otherwise it will be 26. Modification factor. For modification factor we have used this formula, a minimum of 0.55 plus 447 minus G33, that is Fs. G33 divided by 120 into 0.9 H25, that is mu by BD square of midspan. Now allowable length of the slab in shorter span will be round up H32 basic Lx by d into modification factor into effective depth of the slab. Here it is 3661. We have 350 minus 0.250, that is 3250. So it is okay. This is design summary. In the longer direction, we have to provide the distribution bars. The distribution bars should not be less than 8 mm dia, and spacing we have to provide is not more than 5 times of the effective thickness of the slab, or 450. Lesser value among these two values. Now we are changing the LI value to 6000. Two-way slab not applicable. You will not get any value. Once again, we are changing. Now we are changing the bar dia for bottom 8 mm. Here spacing required 94. We have provided 125. So we are getting some warning here. And deflection is also not satisfying. And that's all about my design of one-way slab. Please don't forget to subscribe my channel and also evaluate my performance with your valuable comments. Thank you.